So I was doing question 11. So basically, we're supposed to evaluate this with x squared plus y squared. This is what x squared plus y squared cubed. The square root of that with dx dy, where d is a disk, and x squared plus y squared is less than or equal to 4. So you could correct me if I'm wrong, but it's I guess the radius will be less than or equal to 2. Um, so basically, I just created the integral right here, and then after that, I just put in the preliminaries, and then I just created a circle to just make sure that everything is correct right here. And then just wanted to make sure that we do the x equals r cosine theta, so we have to change the variables. So for x, it's r cosine theta, and y, it's r sine theta. And then you have to put it into the Jacobian matrix, get the derivative for each. So this will be with respect to r, and this will be with respect to theta. And then took the derivative, so each of the derivatives come from here. And then this will be cosine theta, sine theta, negative r sine theta, and r cosine theta. And then we take the determinant of that Jacobian. And then we get r cosine squared theta plus r sine squared theta, which will equal to r because cosine squared and sine squared equals 1. After that, I just took the integral. So we will do it via, one moment. We will do it via this. So we multiply the equation right here. Or not the, yeah, so basically what was given right there. Basically the x squared. So that would be the r right there. And then times r, which would be the determinant we received right here. And then this will be with dr. And then I took the dr, so this will be 2, 0. The radius is 2. And then, well, we get r to the 4th because square root r cubed. 2 is 6. Square root it. I think it's, yeah, so it's r to the 4th. Then we do the integral, and then it'll be 2 to the 5th minus, will be 32 over 5. And then the next one will be for theta, with respect to theta. It'll be 2 pi 0, so this will be 32 over 5, d theta. And then take the integral, will be 32 pi theta over 5. We do 2 pi to 0, so it's 32 times 2 pi, which is, I think, yeah, 64 pi, and 32 times 0 is 0, so we get 64 pi over 5. Does that make sense?
Yes.
Awesome.
Very clear. But
Thank
just
you.
one thing. Just one thing. On the exam, you do not have to calculate the Jacobi of R. You just use the theorem. Right? You don't have to calculate the Jacobi to save your time. Okay.
All right. Thank you.
Thank you. Okay. Next one, Ron, 6.4, section 411.
So my question asked me to determine if the integral exists on a rectangle of basically 0, 1 to 0, 1. And if the integral exists, compute its value. So the first thing I did was I noticed that the numerator is x plus y, but the denominator is actually x plus y squared, which I simplified over here. And the reason is just the common rule from, pre-calc, x squared, y squared, and then in the middle 2xy. So I basically have 1 over x plus y. And of course, the limit as this approaches 0 is plus or minus infinity. It's basically a plot which is like 1 over x. So we have one curve that goes like that and another one that goes like that. So the problem with that is that that point at 0 is basically not solvable, except in this case where it does happen to be solvable for the integral. because, as we know, 1 over x becomes ln of x. That's the integral of it. That's the antiderivative. And because we can solve that for 0, we can also solve this for 0. So I went ahead and I set up the integral like this. The integrand is 1 over x plus y, dx dy, and of course we have 0 to 1. But because I can't really plug in 0, I'm plugging in t and the limit of that as it goes to 0. That basically gives me some leeway if I need to calculate a limit later on, which I sort of do. So this is, becomes ln of x plus y, easy enough. And then I plug in 1 and t. So far, there isn't a limit that needs to be calculated because we have ln of 1 plus y and minus ln of y. They're both defined. But now, as I take the integral of that again, which I basically just used the integral of ln x equals x ln x minus x. So using that here, we have, well, 1 is fine, but t isn't. So what ends up happening is we have 1 plus 1, which is 2, ln of 2, minus 1 and plus 1. These two cancel out. And then here we have minus 1 ln 1. That's just 0. So far we have 2 ln 2. However, plugging in t, which is basically a substitute for 0, we have 1 times ln of 1. So again, that's 0. But here we have the limit of the limit as t approaches 0 times ln of t as t approaches 0. Now, ln of 0 is undefined, but because we have that t on the outside, we can basically see that even though ln will go to negative infinity in this case, that 0 on the outside will basically make it 0 anyway. So because of that, it ends up being 2 ln 2 minus 0 essentially, and so the final answer is 2 ln 2.
Nice. Very nice. Thank you, Ron.
Thank you.
Tanya, next. Then Muhammad Zaman, Walter, Josephine, Liz, Brianna.
So I'm doing from section 6.4, question 3. It says to evaluate the double integral d the function y over x with respect to x, then with respect to y, where d is bounded by x equals 1, x equals y, and x equals 2y. So I first graphed it so that I can see what the boundaries would be. And I got 0 is less than or equal to x is less than or equal to 1. And then to figure out the y boundaries, I just had to take the like x equals y, I had to change it to be y equals x, and then x equals 2y, I got y equals x over 2. So then the boundaries for y was x over 2 is less than or equal to y, and y is less than or equal to x. So I couldn't do it with first doing with respect to x and then with respect to y, because then we wouldn't be left with a number. So it's we want 0 integral 0, 1 to be on the outer integral. So the outer integral is 0, 1, and then the inner one would be x over 2 to x, and then the function y over x with respect to y first, and then with respect to x. So after integrating, we get 1 over x times by y squared over 2, so that's y squared over 2x, and then evaluating that integral, we get 3 over 8x, and then we have to integrate it 0 to 1 with respect to x, and then we get 3x squared over 16, and then we evaluate it from 0 to 1, and then we get 3 over 16.
Nice. Okay.
Thank you.
Thank you, Tan. Muhammad Zaman?
Yes, Professor. One minute. You see the screen?
Not yet.
Yes.
Yes, now.
Okay. 6.3, number 7. Really good. I like the question. A sculptured gold plate D is defined by 0, where no x, which is greater than n equal to 0 and less than n equal to 2 pi, and y, which is greater than n equal to 0 and less than n equal to pi in centimeters, and has a mass density, which is given by the function y squared sine squared 4x plus 2. This is in grams per square centimeters. What we're trying to find out is the actual price after finding the total weight or the mass of the gold in the plate. So of course it's a double integral, and we're given the range or the direction for the x and the y. So of course the first one is x, the outer integral, then the inner one is y, so 0 to 2 pi and 0 to pi. We plug in the function that we had, dy dx, yes, it's two functions. We integrate the original given function, which is y squared sine squared, 4x plus 2. We get y to the third divided by 3, sine squared, 4x plus 2, y. Then we have to plug in the pi and the 0 for the dy. So wherever we see y, we have to plug in the y, and of course it's going to be minus 0. We plug it in, this is what we get. We simplify it, and for the sign, we're going to see that we plug in a trig identity. This is going to simplify the answer even more, and it's going to be easier to solve the problem and go further on. We had the identity plugged in for the sign, so it became cosine. Then we simplified the expression even more. We got pi cubed divided by 3 minus pi cubed again divided by 6 divided by 6, sorry, again, cosine 8x plus 2 pi dx, which is what we have to solve for now. So we're going to integrate again now for dx. So we're going to get pi cubed divided by 6x, and this is what we have right here. We plug in the 2 pi and minus 0 again. We simplify, and we finally get pi 4 divided by 3 plus 4 pi squared. So the question is asking about the gold sold in accordance to the amount of the gold, meaning the mass. So it's saying the per gram is $7. So the total amount of the grams, meaning the total mass, is here. So now we have to times it by 7, because per mass is $7. So the total mass times 7 would be the actual amount of the gold in the plate. So we times the mass by 7. We get 7 pi to the 4th divided by 3 plus 28 pi squared. We simplify that. We do the calculations in the calculator. We get 503.636. We round up. 503.64 is the answer, and it's confirmed by the book. That's it.
Very nice. Very nice. Yeah. Very nice. So, Walter, the next one, Josephine, Liz, Brianna.
Okay, so for problem 6 of section 6.3, we're asked to find the center of the mass of the region between y equals 0 and y equals x squared, and we're also given that x is between 0 and 1/2. And so when we're looking for the center of the mass of the region, we're looking for its x and y coordinates. And so when we're looking, when we're solving for example, the x coordinate, we would actually be looking for the double integral of the mass density times x and divided by the double integral of mass density by itself. And for y, it will be the same thing. We would just be substituting in y for x. And so I start by solving the double integral of mass density by itself. And so we would have an integral of 0 to 1/2 and 0 to x squared of g dy dx, where mass density would actually be a constant both in terms of y and x, and so g would be placed outside both integrals, and so we would then solve the innermost integral 0 to x squared of dy, where we will be given x squared. Then we will solve the other integral from 0 to 1/2 of x squared dx, where we will be given x cubed over 3 evaluated from 0 1/2, and we would get an answer of g over 24. And g over 24 will actually be our denominator. So when we're looking for x and y, we would just substitute in at the bottom. And so when we're looking for x, we would be solving for the double integral of mass density times x. Once again, g, or mass density, will actually be outside both integrals, while x is a constant in terms of y, and so it will be outside. And so we would have we will solve for g, the integral of 0 1/2, x, the inner integral of from 0 to x cubed dy dx. And so our inner integral, we're going to have x squared like before, multiply that by x, and we'll get x cubed. Evaluate it, and you're going to get g over 64. And so when to get our x coordinate, we would divide g over 64 by g over 24, and you would get an x coordinate of 3 over 8. And then you will solve for y, which again you would just be substituting in y in for x. So our integral would be from 0 to 1/2, and from 0 to x squared of g times y dy dx, and you would get g over 324. You would take g over 324 and divide that by g over 24, and you would get 3 over 40. And so the center of the mass would be in these x and y coordinates, 3 over 8 and 3 over 40.
Okay. Just one thing. I noticed that everyone like to see solve in mathematics. You know, when we say solve only for solving equations. All right. So a lot of times in this, we'll evaluate. If we plug in value into something, that's called the evaluation. Well, of course, the integration, evaluation, differentiation, right? Solving is only for solving equations. Right? We'll simplify expressions. Okay, all right, good. Josephine, then Liz, Brianna.
Okay, can you see my screen?
Yes, it's getting up. Yes, now.
Okay, perfect. So I did 6.3, question number 5, and it asks you to find the center of the mass of the region between y is equal to x squared and y equals x, and then the mass density is equal to x plus y. So I wrote on the sides the formulas to find the center. And then first I started by finding just the mass density, so the denominator part. So I took the double integral of x plus y dy dx, and our y's are going to be x and x squared, and then our x's are going to be between 0 and 1. So I integrated with respect to y first, and then plugged in x and then minus x squared, and that left me with 3 over 2 x squared minus x cubed minus 1/2 x fourth, and then I took the integral with respect to x, and then I plugged in 1 minus 0, and that left me with 3/20. And then I did the x component, the numerator first. So you do x times the mass density, and that's going to be x squared plus xy. And then the same process. I took the derivative, not the derivative, I integrated with respect to y first, and then I integrated with respect to x, and I got 11 over 120. And then lastly, I did the y, the numerator of the y component, so it's y times the mass density. I got y times x plus y squared, and then same process, I integrated with respect to y first, plugged in x minus x squared, and then I integrated with respect to x, and I got 13 over 168. And then to find the center of the mass, I divided what I got for the x part divided by when I integrated the mass density. So my final answer is I got 11 over 18 for the x component of the center, and then 65 over 126 for the y component.
All right. Okay. Liz, 6.44. Then Brianna, 6.219. Then Gregory, 6.39. Liz, if you're talking, I cannot hear you.
Can you hear me now?
Yes.
Okay. So I'm gonna present number 4 from 6.4. We need to evaluate this double integral if it exists. So the first thing we need to do is to identify the region of integration in the xy plane, which is like we need to find the limits for x and y, and we're gonna have d that will represent the region of integration, and f of xy gonna be the function we want to integrate. So we have the double integral going from 0 to 1, from 0 to e of y log x dy dx. So the function, like I said, the function we want to integrate is f of x y equals to log x. When we know that the function f is undefined at the boundary points where x equals to 0, and it's continuous over limits when v approaches 0, d over dv equals to limit when v approaches 0 of 0 to e of v times 0, 1. Therefore, if it's integrable over this interval, that we know the given integral exists. So by Fubini's theorem, the value of the integral gonna be as follow. So this, the integral based on d divided by dv log x dx dy is gonna equals to the limit when v tend to 0 of the integral that we had. So we're gonna start by integrate with respect to x. So we have x log x minus x going from 0 to e of v, and we integrate and we evaluate that. We have now e of 0 log e of 0 minus e of 0 and the second part, which is like everything, it's times by 0, so everything is like 0. So we are left with e exponent 0 is 1, so as 1 log 1 minus 1, which is just -1, because log of 1 is 0. So we're gonna integrate this with respect to y, and that's give us y, and we're gonna evaluate it from 0 to 1. That's give us -1 plus 0, which is just -1. So the value of the improper integral going from 0 to 1 and from 0 to e of exponent v log x dx dy over the region D is -1.
Right. Okay. So that's Liz, then Brianna, then Gregory.
So section 6.2, number 19, it asks to calculate the integral, and the region is bounded by the 4 equations that it gives. To start, the first thing we need is to figure out what the transformation is going to be. So we need to figure out what the transformation is, we have to substitute u and v into the integral. So I set u equal to x plus y and v equal to x minus y. Then to start, for the x value, I do x plus y and x minus y equals u plus v, and that gives us x is equal to 1/2 u plus v. Then for y, x plus y minus x minus y equals u minus v. So that y is also 1/2 u minus v. Then for the Jacobian matrix, take the partial derivatives, and that's 1/2, 1/2, 1/2, and -1/2 gives a determinant of -1/2. Then substituting into the integral is actually F composite of the transformation, which is also the image of D star. And after substituting in, we multiply by the Jacobian. So, and for the bounds, we look at the equation, since x plus y is 1 and x plus y is 4, and then for y values, we get -1 and 1. So carrying out the integration, u squared times e to v times -1/2, integrating with respect to du first, gives u third over 3. So then we need to integrate -1/2 from -1 to 1 ev times 63 over 3, and integrating that and plugging in -1 and 1 will give 21 over 2 e minus e to the -1st power.
All right. Okay, so one, Gregory, 6.2.
Sure. Good morning, Professor.
Thank you. Good evening.
Of course. Happy last day of class, everybody. Let's get this presentation going. Okay, 1 second. Share the screen right now. Great. Okay, can we see this? Yes, I hope so.
Yes.
Lovely. Okay. So I'm doing question 9 from section 6.3, applications. And so the first question, part A, says find the mass of the box, and we get these coordinates for our bounds of our integral, and assuming the density to be uniform. And we know that our density would be represented by delta of x, y, z. And so we can have our function here of mass over the range of d. And so we can just rewrite our equation like so, where delta of xyz is our mass constant, right? And there's no need to write all these variables out since we already know what it is. And we know that it's a constant, so we can apply the rules of our constants in integration. And we can just move that delta right on the outside of our integral based on that rule. And we can go ahead and start evaluating the integral. So for the first part, dx with the integral from 0 to 1/2, you'd get 1/2 as your result. And taking that result, applying it to the second integral with respect to y on the range of 0 to 1, you would get, again, 1/2. And then you do it one more time, and we would go ahead and get 1 for our result of this integral. And we can bring down our delta constant, and so that we can find our constant of this figure of the box to be uniform as, again, the constant, right? And so for part B, we have the same question, but now we're actually given values for x, y, z for this function. And here is the function labeled. And so we can go ahead and set up our integral again the same way, but this time we actually have a function to integrate. So there's no moving delta outside, yada, yada. And so we can go ahead and do the first integral with respect to z. We can see that we pick up a constant z, or not a constant, a variable z for each one of these terms. And we can evaluate it at 0 from 0 to 2. And we can find that this would be our resulting integral. 2x squared plus 6y squared plus 2 is 4. We can also then factor out 2 since, we have a 2 here, a 2 here, and then this is 4. And we can bring the 2 out in the front again. And once again, now we have a constant multiplier, so we can take that out. And now we can do our integral again of this part. And so we can do it from the bounds of 0 to 1/2 with respect to x. And we go ahead and do that. And then we do it again, another time, and we evaluate the integral. And we bring down this constant 2 that we picked up over here. And we can find out that our integral is now 37 divided by 12. So pretty simple.
All right. Okay. All right. Anyone else like to present?
Thank you.
Yeah. You're welcome. Thank you. I realized I haven't done something about homework, the complaints about homework 2. And for this homework 1, I will check this. I wrote on my notebook, but somehow I forgot to check it. All right, to answer this question, if you have any complaints about your grades, I will be back to in NY on 25th, so which is a week later. Today 17, right? I'll be flying 24th. I'll be arriving 25th. So, right, you can email me, but I won't be able to see your emails until August 25th. I really feel deserted here. Let's see, any other questions? So about final exam, Brianna, you want me to check your homework 4 says in progress? Okay. Oh, my email, okay, let me show you this. My email is a Chan, let me type in here. Okay, that's my email, chan.chen@brooklyn.cuny.edu. You're welcome, Gabriel. So final exam will be exactly like this, exactly, similar to midterm. That's your midterm. So this is the final exam. Because we have midterm experience, so no more excuse. I won't be able to recreate. I don't want to recreate resubmission for midterm, all right? It's the same format, same format. You already have experience, so no more excuse. And this will be our final thing. You guys have studied very hard, worked very hard for this summer. So this is just the last part of it, final exam. And it'll open at 6:30. Only the final is weird because on top shows 2022 fall. Just ignore that, all right? Because I cannot access Google. I cannot edit my files. So those I just use the old ones. Let me see your question. It's the same thing with the whole ID. Yes, because this is online. It's just to show you did your exam. Yes. Yeah. But it'll be a lot easier because I have your handwriting already. It'll be a lot easier. What else? What else? Yeah, same thing. So let's try to get online like a couple minutes earlier so I can check your ID. But I can do that at the same time, while you're taking your exam. Let me change my alarm. Let me change my alarm to be 6:20 so we can get online a little early. All right, I have changed my alarm. How many questions? I remember 12 questions. Let me check. One bonus question. 14 questions, 13 mandatory, or 14 bonus question. All right. Okay, what else? It's final 2 hours. Yes, 2 hours. I give you a couple more minutes to upload your work. Let me see. The final will have same topics like the previous chapters. Yes, it's cumulative. Final is cumulative, but more towards integration. All right, any other questions? How much will we have to know about section 3.4? What's section 3.4? Lagrange multiplier. Oh, Lagrange multiplier, you have to know. It's a very important concept. If you major in any science, it's a super useful concept. Actually, nowadays, statistics is very popular. Even you don't do science major, even you do other science major, because you want to use the skill of statistics, right? The skill of mathematics. Some mathematical concepts are super important, are very useful. Because imagine the object doesn't have to be a picture. The object could be anything. Let me see. It's section 6.4 on the exam. 6.4, maybe only the ones listed as optional are not on the exam. Okay, are surely not on the exam. All others are possible. 6.3 and all the optional sections are not, right? Optional sections won't be on the exam. Homework 6, all sections required, not all sections, only 4 sections, 6.1 up to 6.4. So 1, 2, 3, 4. Other questions? Right, you can prepare a cheat sheet. So 8 by 11.5 inches, just 1 page. You can write it back and front and back, okay, but just 1 page. No, everything finished today. I mean tomorrow. Everything finished by tomorrow. Can I go over 6.1? 6.1. What do you mean? A question in 6.1? What do you mean? Quickly
Just
go
like
over.
because I'm having a bit of trouble understanding that chapter. Can you like quickly go over it again?
No, I'm not going to. You can watch the video. You can watch the video I recorded. If you have a typical question, I can talk about it. But I'm not gonna go over the whole chapter about 6.1. You just go back to watch the video, okay? Every class is recorded. Can you explain the transformation that was done for section 6. Example 3? Yes. This question I can answer. 6.2, 6.2, 3. If we have no questions, are we free to go? Yes, Gabriel. If you have no question, you're free to go. I could give you Matum key, so we can review that we did. Any chance you can upload that? Matum key. I don't have Matum key. If you have a typical question, I can answer that. I did not, because if I were in America, if I were in New York, you know, I'll be able to do that. But now I'm deserted in here. I cannot create anything. I don't have any application to work on. I used to work with Google Drive, but I don't have access to that. Okay, if you guys are going, good luck tomorrow. Yes, Ivy, I forgot to do that yesterday, so I'm going to do today.
Okay,
Yeah,
thank you.
I circled it. I make sure I'll check today.
Okay, thank you. Have a nice day.
You too. Walter, what do you mean you too? You too? Oh, yes, homework too, yes. I have Liz, I have Jean E, I have Ivy, I have Walter, I have Josephine. Yeah, I'm going to check. So now let's go to 6.2.3. Actually, can you, who asked this question? Brianna, can you share your screen with me?
Yeah, just give me a sec to get the page up.
Okay.
Thank you, Professor. Have a good day.
You too. Thank you.
Alrighty, bye-bye. Take care.
Bye. See you tomorrow.
See you tomorrow. Goodbye, everyone. Good luck.
Can you see my screen?
Yeah.
I don't understand where T of UV, that part came from.
T of UV, that is, well, you're given this, right? Y, no, x equals to u minus v. Y equals to 2x minus v. That's right here.
Oh, it's because we're given.
Yeah, T of UV just tell you transformation transforms UV to be u minus v to u minus v.
Okay. If we weren't given the x and y transformations, how do we go about it for this question?
Let me see. Let P be the parallelogram bounded by this, and this. Evaluate this, making the change of variables. You won't be able to do anything if you are not given the relationship between x of UV, y in terms of UV. So this is giving you x is a function of UV, y is a function of UV. That's a transformation. If you're not given this, what can you do? You cannot do any transformation.
Okay. 'Cause I was just like, I was trying to relate this question to what I did in question 19, where I had to find the transformation.
Well, that's different. Maybe sometimes they give you, like, they give you some hints, they give you some settings, they ask you to find transformation. They're different questions.
Okay. How would I like know like when I can do the transformation? Like
Well,
yeah.
For those examples, right? Let's see this example. If you are given P, you see this P region, not the P star. Comparing to P star, what can you see about P? You integrate an integrand over this region P.
Okay.
What's the difference about P and P star?
Oh, so in P star you're given the vertexes, but in P you're not. So if you wanted to.
No, P you do have vertices. Both you have vertices.
Oh,
what's the difference? You integrate something over those two regions. What are the difference about those two regions?
One is stretched.
Well, if you set up integration, right, you have lower limit, upper limit. Which one is easier?
P star, because it's
okay, so P
vertical and
star
horizontal.
Right. So P star, so U goes from 0 to 1, and the V goes from -2 to 0, right? You have this upper limits, lower limits to be constant. But what about P?
You're given the equations of the lines. So
if you integrate anything over P, what do you do? How do you integrate?
You'd have to like split P in half. Like you could do like y equals 2, so that you're integrating from 2x to x.
You have to split into 3. Into 2 is not enough. You have to split x-axis from 0 to 1, 1 to 2, 2 to 3. You have to split 3 parts to be able to integrate. Right?
Okay.
So it'll be much easier to integrate something over P star than over P. So that's why sometimes we do transformation. But this is not crucial because we can split into 3 parts. We can integrate. That's not a big deal. The big deal is some other things. You have to use, it forces you to use the polar coordinates, forces you to use the cylindrical or spherical coordinates. That's when you know, right? The integrand, you won't be able to integrate on x, y, z coordinates. You have to do the homework, okay? You have to do the homework.
Yeah.
If you don't do the homework, it doesn't make sense for you.
Yeah. Okay. Yeah, I just wanted to like confirm that because I was just like struggling to understand. But thanks.
Right. And yeah, I could see that this course is difficult for you. All right. But try your best.
All right. Thank
Try
you.
your best. You're welcome. All right. Ryan, any question? Yes, Ryan.
Professor, I'm sorry. With the change of variables,
Yes.
I know how to do it, but
Okay.
how do I determine the new bounds of the integral?
Depends. Depends. When you change the variables, the bounds changes accordingly.
Yes.
Depends on which question. Can you just bring up one question so we can talk about?
Sure.
Okay.
Because I actually, I don't have my homework scanned, but
Okay.
it was question 4, and I
Okay.
got stuck at the bound. So, obviously
This
the
one?
integral, yeah, it was 4. So the integral
Okay.
becomes u plus v, or 2u, because
Okay.
it's u plus v, u minus v, so it's 2u. But then I got stuck in evaluating the bounds because I just can't see it. I don't know. Like with polar
Okay.
coordinates, I can see the circle.
Okay. The bounds basically the inverse function of u in terms of xy and v in terms of xy.
Okay.
So you have D region, right?
Mm-hmm.
Your D region is x goes from 0 to 1 and y goes from 0 to x.
Mm-hmm.
And you could use that, you have to use that, and also this two equations, x equals u plus v, y equals u minus v, to solve for u in terms of xy, to solve for v in terms of xy.
Okay.
You can do that, right? Right.
Okay.
So
yeah.
once you do that, the submit, you just plug in the bounds of x, plug in the bounds of y. Then
Now
you find the representation of the bounds in terms of u and v. Yeah.
I think I did do that, but I wasn't sure if I was doing it right. The problem
did
is
right.
I got so I believe the solution is along a triangle, so 3 lines. But
Yes.
when I plug in x equals 0, I get a 4th line. So I wasn't sure what to do with that. And
When you plug in, okay, let's do this one. So x equals to u plus v, and y equals to u minus v, right? If we add these two, we get x
yes,
plus y equals to 2u, which
yes,
is u equals to x plus y divided by 2.
yes.
And the v equals to, we subtract divided by 2, which is, this is one of the example. One of the example.
Ooh, which
So
one?
you have
I'll actually take a look at it.
That's I think example 2 or 3. So the
Because I couldn't
transformation.
see it. Do you mind if I scroll up actually to see if I could find it?
No, let me type in the chat. So T of hold on one second. Let me see make sure the presentation. So u equals to u of xy equals to x plus y divided by 2. V of xy equals to x minus y divided by 2. So we have those two. Now you know this is triangle. So x goes from 0 to 1 and y goes from 0 to x. Right. So let's see what else. So then your u equals to, so the lower bounds, let's see your problem is. Your lower bounds, u and v both goes from 0 to something. And the upper bounds, because your x goes to 1.
One of the upper bounds is 1 plus x.
Right, 1 plus x. That's for u, upper bounds. What about for v? V,
I think it's 1.
V equals to 1 minus 0. Okay. All right. So what's your question?
Just like what exactly to plug in? Do I plug in X and Y at the same exact time?
I see.
Like when we have what was it? U equals X plus Y.
Half of X
over
plus
2.
Y, right?
Mm-hmm.
Right.
Do I plug in 0 and 0, and then
Yes.
0 and 1, and 0 and X
Yes.
and X and 1? Okay.
Yes.
That's the part that I wasn't sure about.
I see. Okay.
Okay.
All right.
Thanks for the help, Professor.
Okay. Oh, you're welcome.
And can I ask you just one more question? I'm sorry.
Of course. Go ahead.
So I didn't skip any sections in a homework. I still have like
No.
3 sections left to do, but I think I'm probably going to do them. Am I still gonna get credit for the sections I should have skipped?
Section you skipped? What do you mean?
So I
It's
didn't. I did all the optional ones. So I'm wondering if I'm still gonna get credit for them.
Oh no, optional ones you don't get an extra credit. Not for homework. No.
Oh, okay.
Okay.
Now, considering that since I didn't skip the optional ones, can I skip like 3 sections now?
Yes, you have the choice. You have the choice.
Okay.
Yeah. Okay.
All right. Thank you, Professor. Have a good day.
You too. Okay. Thank you, Brianna. Liz, do you have any question? All right. See you tomorrow and good luck. All right. Let me see.